Hello everyone, today we are going to solve remove n node from the end of list. So given a linked list, remove n node from end of list and return its head. So let's see the example here. Okay. So because there's a requirement that we can only do one pass, means that we can only loop through this linked list one time. We have used a technique called two pointers. So we have to use two pointers, okay? And how to solve this question? We have to create a dummy node that links to the linked list, and we have to also create a fast and slow pointer. In the beginning, they were assigned to the dummy node. Okay. And later on, the first thing we have to do is to move the fast pointer n nodes. So it means that in here n is 2, right? So we have to move 2 nodes, 1 node, 2 node. Later on, we have to move both slow pointer and fast pointer together until the fast pointer to the end. So move the fast and slow pointer. Okay, both the fast and slow pointer until the fast pointer to the end of the node. So let's see how to do that. Okay. So we will move fast 1 node, slow 1 node, right? Fast 1 node, slow 1 node. Fast 1 node, slow 1 node. Until fast pointer to the end of node, right? And then what we should do the last is that remove the next node from the slow pointer, right? Because the next node for the slow pointer is the node we want to remove, right? So we just remove it, right? Use s.next equals to x next. We can remove the node fourth, right? So that's how we solve this question. So I put the step here. And let's see the code in action, so you will have a better understanding. Okay, so let's see. Let's check the boundary first. If the head is new, so we just return a head, right? It's nothing, cannot do anything. And then we have to create a dummy node, right? First, dummy. So equals to list node. And then we have to link the dummy node with our linked list. So dummy next equals to our head. Okay, so that's it. That's this sign means. And then we have to create a slow pointer, a fast pointer, right? Fast, slow. Right. And they are in the beginning they were assigned to the dummy node, right? So they will point to the dummy node. So I just say dummy. Okay. And we have to move the fast pointer a node first, right? So for n equal to 0, fast equals to fast.next, right? And n minus dummy. So in here we will just remove 2, right? So n equals 2, 1, 0, right? And later on, what we should do, step 2, move both the fast and slow pointer until the fast pointer to the end of the node. So until the fast node to the end of node. So as long as the next node of the fast pointer is not equal to nil, right? So as long as it's not equal to the nil, we just move the both fast and slow pointer. So the fast equals to fast.next. Slow equals to slow.next. Okay. And then So we will become something like this. Okay, fast next equals to new, right? And step 3, we have to remove the end node from the slow pointer. So in the end, we just have to remove the next node from the slow pointer. So slow the next equals to slow next. And wait a second, fast. And later on, because we use dummy node as the starting point, right? And dummy node next points to the head, right? So we just return dummy next. And yeah. And the time complexity for this algorithm is only because we just one pass. We just loop through the linked list one time. And the space complexity is O of 1. O1, yeah. Because we don't use any extra space. So let's see. Okay, pass and submit. And yeah, that's it. Thank you for watching.